And I was thinking, well, I mean, aren't we going to miss some things? And we're not. We're, in fact, going to get what we learned from Chapter 8, and we're going to apply it directly in Chapter 10 because there's a lot of relationship. In fact, there's going to be a lot of familiarity here. Okay, we're going to first try to identify quadratic functions, and then we're going to look at their graphs, but then we're going to actually start making those graphs on our own. So we're not graphing ourselves. We are just looking at the graph and identifying parts. So the first thing I want you to get is what we call standard form of a quadratic equation. F of x equals ax squared plus bx plus c. F of x equals ax squared plus bx plus c. Oh yeah, we've had f of x. We'll review some of these things, so super important to get it. Okay. Yep, it's standard form right here. And there's one thing you need to remember about a quadratic equation. It has to be in this form in order to be able to look at it more appropriately. But then a, this value, cannot equal 0. A cannot equal 0. That's one of the only limitations on that quadratic equation. Now, have you ever dealt with equations? Yes. Have you dealt with this equation? Yes. Have you dealt with it recently?
Yes.
Yes. So recently, it was almost like yesterday. Wait, it was yesterday. Okay, look at this right here. Look at this right here. And what kind of polynomial is this right here? Trinomial. And do you notice? Yeah, it's quadratic. Do you notice that the highest exponent is 2? And do you guys remember that in my chart that I was and you were and you did, and hopefully you did well, you were factoring quadratics? You had 3 different ways to do it?
Yeah.
Okay. Quadratics, or quadratic equations, quadratic functions, are just equations that have the highest power of an exponent being 2. That's all it means. In fact, yes, it is easier. In fact, all that factoring that you've done, you're like, oh, I'm so glad we're done with that. It's going to come back. It's going to be a little bit more clear to you because of practice. And it's going to be sometimes one of the only ways you can solve an equation is by factoring it. So make sure you guys don't just totally forget that chart because it's coming back and you need to know it. But yeah, we looked at this yesterday. It's really not that different. You're like, I haven't looked at that. I don't know what you're talking about. Well, that's not a good sign. Okay. You can also see it in this format. Also see it in that format, and we'll see a lot like that today. So these are both standard form. And what can A not be? 0 on both of them. A cannot be 0. B can be 0. C can be 0.
Y can be 0.
Y can be 0. Yep.
So
They're all
The only thing that can't be 0 is this A. A values can't be 0. Okay, now listen carefully. This right here, I'm going to show you here, and I've said it before, but I really want to drill it because geometry talks a lot about it. Let's look at both of these. What's the only difference between these two equations?
Fx and y.
Okay, f of x and y. That's the only difference. They're both the same thing. So, this is what you need to get in your mind. This is logic. If f of x equals this, and y equals the same thing, what do you know about these two right here? They are equal to one another. That is called the transitive property. If one thing equals, I'm going to use the word blah, and another thing equals blah, then what do I know about those two things? They are equal to one another. That's the transitive property. And in geometry, when I tutor students, that's like one of the hardest ones. Like, what did you, if this, then that, then this? What? That's transitive property. I hope you can get that pretty quick. Yes, ma'am.
Sorry, this is a stupid question, but what does f of x mean?
Yeah, so f of x literally means y, and you're like, okay, why don't they just say y? Well, when you write f of x, you're using what we call functional notation. That means you're not just saying that these are related with an equal sign. You're saying that they're related as a function. Like, this is a function automatically because of that notation. So yeah, it's more specific. Okay, I hope you guys know that one. Let's look at a couple things. Okay, A. Oh man, I shouldn't have put that up there. Do you remember what A is? the number in front of the x squared? It's the lead coefficient. And you should have known that from the chart because I put lead coefficient equals 1. Lead coefficient does not equal 1, right? So A is just that lead coefficient. All right, in quadratic equations that we're talking about today and tomorrow, there are two scenarios I'm going to give you for the first part of the lesson. A is greater than 0, okay? If A is greater than 0, then we're talking about a specific type of shape. Okay, let's talk about that shape right now. So we are talking about quadratics. Okay, when we talk about linear equations, you know what kind of graph a linear equation has? A line, okay? I hope that's not too confusing. But when you get a quadratic, you don't get like a box or a rectangle or a square. You get what we call
upside down here.
a parabola. Parabola.
Is a parabola?
Yeah, write this. You need to know what a parabola
Same thing as upside down one of those things?
Yeah, same thing. You can have the one, and we'll talk about what's the difference. Yes, we've seen some graphs like this, and then you've seen a lot more than you thought. Maybe you weren't looking for a parabola, but you saw it and you used it. In fact, most of you in this classroom have used parabolas for your advantage at Mitchell Road. Okay, ready? Not in class. Not even in class. I'll show you why. Okay, look at the picture on page 246. You guys see those that picture of the night sky with the water fountain? Okay, do you notice the stream of water from one of the it is making a parabola. It's making this shape right here. That's a parabola. And you also have parabolas that are shaped like that. So some people say like an N, some people say like a U. Okay, however you want to distinguish it, but we're going to get more technical with that. But these are the two types of parabolas. And not all parabolas are that wide. You can get really steep parabolas. You can get really, really wide parabolas. Sorry? No, that's too fun to talk about parabolas. Okay, you know kickers and receivers, they know about parabolas. And the more they know about them, the better they can be because they're getting technical knowledge. Like a kicker, I'm thinking, what does a kicker do during practice? He probably kicks. But he's trying to learn, how can he get something like that? How can he get something like that? Maybe something like that, right? He wants to get something like that. Now listen to me. When have you used or seen a parabola? Anyone want to give me an example? Raise your hand, raise your hand. Sorry, when have you seen it? Michael?
This morning.
Sorry? Soccer. The ball, when you kick it up in the air, will travel in a parabola. Yes, ma'am.
Does it have to be going up?
It can be going down or up.
Okay, baseball. Baseball.
Wait, what's right? Yeah. Or like below. Can you think of anything?
Like a swing.
A basketball?
But I guess not.
It's not perfect, but it's that shape.
Something else.
Let me get some examples from you guys, then we can come. Yep.
The water fountain.
The water fountain. Yep. The water fountain goes like this, or it can go really high. Okay. Anything else? Yes, sir.
Can it open right or left?
Right. I mean, yeah. Like, can it open here or open there? Is that what you're saying? No, not parabolas that we're talking about. Not like that and like that. There are other shapes, other things that do that.
Would like a U parabola thing, like a bounce pass and that?
Yeah, that's very nice. That bounce pass, or like a swing of an object, like something. Yeah, a clock. Has that kind of shape. The little tick-tock part. I think if I'm looking at you guys correct, if I'm thinking about you guys and what you do correctly, I would say maybe 70% of you in this classroom have used a parabola here on campus, and you use it for your advantage. And you were thankful for it because it helped you out in whatever you were doing. Maybe you didn't do it well, but you used it. And the thing is, parabolas, guys, are everywhere. And here are some other examples. In physics, you talk a lot about parabolas in physics because you can come up with it. You start looking at physics, and what subject is physics, by the way? Science, right? So what happens is this. You start talking about objects that travel, and you can tell me how long it's going to take for that ball or that bullet or that object to go like this.
Never shoot a bullet in the air. That's why.
You know why? Because you're going to do this. It's going to go up in the air for a long time, and then it's going to drop. But someone said in the other class, what happens if you shoot a bullet in the air? Are you going to die? Well, this is what happens. Yeah, it makes it to space. What happens? It stops for I don't know, I can't say a second, but just a fraction of time. It stops, and then it goes down. And what happens is you're like, well, it's really high up there. It is. But what happens when it's coming down? It gets faster and faster and faster, and then it stops getting faster. There's what we call terminal velocity. When a skydiver comes from whatever vehicle, air transport, they are coming down. They go faster and faster and faster until they hit terminal velocity, which means you don't get any faster. You just stay. Yes, yeah. It can only go so fast because what happens is the pressure of the air and the gravity, they're meeting at the same point. So it's like they're just constant and they will not go any faster. It doesn't mean you stop. Please don't try that. It just means you don't go any faster. You're not picking up speed. Okay, but anyway. Yes, please don't try this home. Let's look at these two. The reason I brought up these two is because they tell us something about the parabola. So I'll wait for you guys. Look at that.
Oh my God. We're thinking about how to use parabolas.
And I don't mind waiting. Okay, so here I have a parabola where the lead coefficient is greater than 0. You know what happens? I know what kind of parabola it is. It's a parabola that opens upward. Opens upward. Yeah, opens. What are you talking about? All right. It opens like that. That's an example of an opens upward parabola. Opens upward. So it has, you could say this. If it opens upward, that means it keeps going up. When does it stop? Infinitely. Good. It just keeps going. It never stops. Okay. Sorry? It's kind of like a line that never ends. Yeah, it just keeps going. But objects in nature, they will have a stopping point, or they will have...
Will they ever meet, like the two lines?
No, they shouldn't meet if they're traveling in that parabolic function. Yep.
What do you call it? Is it still a parabola when it goes like...
Oh, okay, those are sine and cosine waves. And that's... No, those are not parabolas. They're sinusoids and... Yeah, that's pre-calc stuff. You'll get that. All right, if the lead coefficient is less than 0, guess what happens there? Opens downward. And thankfully, they don't switch it up on us. You know, see, here's the thing. It's nice that if it's less than 0, it opens downward. If it's greater than 0, it opens upward. And no one decided that. No one's like, you know what? I think that's what it should be because it makes sense. That's just how it is. Mathematically speaking, that fountain, it's going to open downward. You're like, wait, because doesn't it go down? So that one has a lead coefficient that is less than 1, which is negative. Good. Okay, now listen carefully. You see how I have greater than 0? And you see how I have less than 0? But I'm missing a scenario up here.
Equal. Greater than equal.
Equals, right? Equals.
It's a line.
If it's equal to 0, it's not a parabola. It's not. It could be a line. It could. Yeah, it could. And it usually is, I would say.
You could say it's equal to anything but 0. So it is equal. Facts.
So mathematically say not equal to 0. Okay, write this down, please. Just write this equation down. And we're going to look at it a couple ways. Okay, this is an equation, y equals negative 2x squared plus 5x minus 2. And it is written in standard form. Because you have the x squared, the x, and then the constant.
It's going to be an orange.
So, it's going to be a parabola because the highest exponent is 2. For that x exponent, it's 2. And I know that the a, what does a stand for again? Do you guys remember what a stands for? The lead coefficient is going to be negative 2.
It's going to be an arch.
So we're going to say a lead coefficient of negative 2 is A, therefore, less than or equal to, less than or greater than 0. Okay, so it opens downward automatically. Just by looking at the equation, it opens downward. It's going to be the N shape or the arch, however you want to say it. It's going to open downward. Yes, ma'am?
What did you say about the x squared? I had a...
Yeah, so you see how you have x squared, x to the first, and technically x to the 0? What's the highest exponent of x? 2. So if it has the highest exponent of 2, we can start thinking parabola. You can almost start thinking, my graph is going to be like this or like that, some form of these two. And you're like, well, how do you know which one? Look at the look at the lead coefficient, and it opens downward. It does this. And if you guys need a picture, it does that automatically.
What's the highest exponent like from
Lower, if it were 1, right, so 2, it'd be a line for the most part. And then if it were 3, we'll get to that later. Okay, yes, it's a shape that we do see, but it's people think I'm joking around when I draw it, but it's real. Okay, yes, sir. Did you have a question?
Yes.
Go ahead.
So, first thing, we have to find out on this graph, right?
You're not. Oh, not yet.
Wait,
We're just looking at the equation.
For this, it could be like plus. Could it be like plus 0x?
No, that's not very well. Yes, it can. We'll look at that.
It can't be.
Okay, what I want you guys, we'll get to that because that's a good scenario. Look at this problem right here. Just write it down. Y minus x squared equals 3 plus 2x. Okay. On this, is it written in standard form? No. In standard form for a parabola, the y has to be by itself or the f of x has to be by itself, and the y is certainly not by itself. So how do I make the y stay by itself? Yes? Both sides get added with x squared. I'm going to do it this way. Someone had a question in the other class that I'll try to anticipate. Okay, Mr. A, why did you put the x squared under the 3? Why wouldn't you put it under the 2x? Well, these are not like terms, but neither would these be. But when I write it, you don't have to write it in a specific spot. The reason I write it here, this is my logic, that cancels out. I get y. That's a good thing. I want y by itself. Is because standard form, which one of these terms is going to come first? X squared. Then what comes next? Plus 2x. And then lastly, plus 3. Yep. You need to be careful and you need to be good at writing in standard form.
I was going to say 3.
They don't, these are not like terms. Those are not like terms. Yes. Yep. Standard form because you'll see things a lot better. Now, Rachel, what is A in this equation? 1. The lead coefficient is 1. That means A is greater than 0, which means this graph opens upward. Opens lead coefficient. When you write in standard form, it opens up for now.
Are we only trying to find if it opens up?
But it has
for now. No.
It's
going to get more. I split this lesson into 2.
Wait, so are you saying
super
it's going to get more
easy?
Today or next?
Today I give you a little bit more, and then next class it gets more complicated. Yeah. Okay, it is easy homework. Yes, enjoy it. Okay. Go to page 249, and this was...
Wait, so
okay.
what's like on...
Page 249, on the try these, I want you to do number 6.
So are you just trying to say if it's
upward or downward?
Oh, okay.
But I need you, listen, on the homework when it says do it upward or downward, you need to write it in standard form. I want to see standard form. Number 6 on the try these. Get in standard form, then tell me upward or downward. And I'm sorry about that little... Is that it? No, that wasn't it.
You're just trying to get y alone.
Y alone. And then in standard form. Okay, Jensen, what's first?
Didn't you have to find out where it goes on a graph by using an equation? Like y equals x equals and you put that on there?
So the actual graph, we're not doing it. Tomorrow we're going to look at how do we make graphs. But we're just looking at if it opens upward or downward. So if you can find that out, you're good. Yes?
When you did the last problem, or that one, when you added, how do you
you know, like to do x squared and not like 2x?
Yeah, because I want to get y by itself. So y was being subtracted with x squared. I want to add it.
For number 6?
You want to do what to get y by itself?
Well, there's 2.
So you want to subtract 5, right? To get rid of the 5. And you want to subtract 2x squared.
Yeah, I like the thing that you said where like if there's on the other side,
Change side, change signs. Yep. Which, it's okay. Yep.
There's no 3 terms when you have y by itself. Is that, do you have to have 3 terms or can you just go?
So how many of you got maybe, I think it's this one.
Yeah, 2.
Yeah.
That's what I got.
Uh-oh. Oops. Okay. Wasn't it y equals ax squared plus bx plus c? Where's the bx? It's gone.
No, it's 0.
Okay, ready guys? Tie in. We're going to tie something in. Do you guys remember dividing polynomials? Do you guys remember when you didn't have the x term? What were you supposed to do? Place value holder. So technically I could have said this. Negative 2x squared plus 0x minus 2. Oh, wait, Mr. A. You said a cannot equal 0. Oops.
That's not A.
B can be 0, but a cannot. It's still a parabola. And what is a in this problem then? Negative 2, which means this opens. And you can just write downward. You need to write downward. Mr. A, can I just write down? No. Downward, upward. That's all you had to do. But Mr. A, up is so much shorter. Yep, you're right. Upward. Okay, yes, sir.
No, I got it.
That's okay. All right.
So we take like the a equals negative 2 and our answer? Or?
No. All I want on your answer is this, or either this or this, either one, standard form, and then that. I'm just doing that so you know what I'm talking about in your notes. You're like, wait, how
Will we get any of them that are like not parabolas?
Not today. Yes, 2 answers, the equation and the opens downward. Yes, ma'am?
How do you figure out if it's a equals less than 0 or a?
So you just look at the number negative 2. Is negative 2 greater than 0 or is it less than 0? That's what you're comparing it to. And you're like, wait, it's negative. It has to be less than, so it's downward. Yep. Okay. Let's look at a couple more terms. This is the last thing, last part. Write this down. Vertex. It is. And thankfully it worked on the day that I went too long on travel. But that's okay. You guys forgave me on that.
That was a good
Was it the first time or no? I can't remember.
Sorry?
Short time, I realized.
Yeah. Well, it was funny because Mr. Thomas is back there and he was being very kind. He was like this. I was like, So that usually happens when I'm preaching. Yeah, I was very.
You should get bonus.
Oh yeah, and then we wouldn't have gotten to this.
Oh no.
Oh no.
Okay, anyway.
I wanted to sing another song. John doesn't like sarcasm.
Okay, look on the top of page 247. On page 247, you're like, what are you talking about? Vertex and minimum and maximum? Okay, I need all of you to look on that page because you won't be able to see it. I'm not drawing that on the board. It's very hard to draw it on the board, and we're going to use graph paper when we do it, so we'll have time to do it and more accurately do it. Page 247. Okay, look at the very top. You guys see that there's a red parabola and a green parabola. Okay, so what I want you to do is I want you to look at the red parabola, and what's the equation of that red parabola? F of x equals 0.5x squared plus 4x plus 2. That parabola opens upward because what's A?
Positive. Greater than 0.
Greater than 0. Yep, it's great. And yes, you can say positive, that's fine. So it opens upward. Great. Okay, but do you notice that red parabola, it never stops going up. Never stops going up. It goes up forever, technically. But it does have a bottom. It does have a point where it never goes, it doesn't go past that point below. Okay, ready? The vertex is called the turning point of the parabola. Are you guys looking at the red graph? Do you see where it says vertex? Yeah. Do you notice we define vertex as the turning point? A point has to be x comma y. It has to be x comma y. What is the turning point of that parabola in red? -4, -6. Could it be -6, -4 on that one?
No.
Because it's an ordered pair. It has to be that order. Okay. Now, look at the green. Look at the green parabola. It has a high point, but it doesn't stop going down. It goes infinitely down, but it does have a high point. What is the vertex of the green? 3, 3. Can you say 3, 3? You can mix them around, thankfully, because that's good. Now, yes, sir.
Can you find the angle of a parabola?
I think okay, that's beyond us. You can find the axis of symmetry, which we're doing tomorrow. And you can find how to graph it without them showing it to you. You can do it yourself. Oh, but anyway, okay, a minimum value is called the low point. The low point, right? The minimum value is the low point. But when we're talking about minimum and maximum value, it's a little bit different than the vertex. So vertex is one thing, and these two are another thing. So let's see here. Okay, a minimum value only applies to graphs that are parabolas that open upward. You guys see that it does not have a maximum point, but it does have a minimum. And what's the minimum? It's right there. It's on the bottom. Minimum. Okay. That's the minimum point. Maximum value would be the high point. There you go. That's it. The high point. Yes, I hope it's logically there. And that would be the top point right there. But Mr. A, what's the difference between the vertex and the maximum minimum value? Not much. In fact, I'll show you how you work it out. It's actually very nice to do. Okay, but do you guys understand what a high point is? Now, can I ask you this?
No.
Is there a parabola that has a high point and a low point?
No, it's not a parabola.
Technically not. Okay, and that's another shape. It's not a parabola. Good.
This thing is.
Let's move on. Look at number 7 on the try these on page 249. We'll end it here. 249. Number 7. I want you to give me the vertex, which is called the turning point.
249.
Page 249, number 7. So we're just doing 2 things today. Well, technically 3. Later. That's tomorrow. I'm going to do that. And that is going to be a little bit tougher, but I'll save it for Friday.
Wait, what am I giving you? What am I giving you?
The vertex. And on this one, I put maximum value. You're like, wait, how do you know it's maximum or minimum? It has a high point. It does not have a low point.
Wait, is it? Oh, that's all we put?
Okay, yes. So who can give me the vertex? I think that's the easiest one. I hope you get it right. Yes, sir.
0, 9.
0, 9. Could you say 9, 0? No. It has to be 0, 9 to be correct. So that's my vertex. Okay, that's the point where it turns. It's the very top of that parabola. And it has a maximum value of 9. You're like, okay, where'd you get that? I got it from the y-axis. Okay, you're just looking at the y-axis because parabolas, they're going to open downward. So they're going to do like this N shape, or they're going to open upward. And they're going to be like this on the graph. They're going to be somewhere around here. And when we're talking about high point, low point, we're talking about the y-axis. Y-axis is all I want. I don't want the x-axis. I want the y. Look at number 10. There are graphs that do that, but they're not parabolic. No, these are parabolas, and they have a parabolic shape.
Those things are parabolas, the things that go sideways.
No, they're not. They're not. They look like them, but they're not. But it's complicated. Hold on, number 10. All right.
4, 1.
I got 1, 4.
Oh, that's incorrect.
Wrong. You have to do the X5.
Thank you. 4, 1. What is the maximum value? 1. And you're like, how'd you figure that out? Well, what's the highest y number that graph can have? 1. It has how many points on it? Infinite. And the highest y value that it can have is 1. Out of all those, that's the highest one. That's a peak. And then same thing for the other one. The highest is 9. Yes, ma'am.
For minimum, do you look at the y?
Y-axis. Don't look at the x. Look at the y-axis. So what's the minimum one?
Can we just put max value?
You may. 2 through 18 even. Yeah. All right, have a good one, Swivel. Goodbye.